Hi everyone. Hope you're having an amazing day at MLDS 2024. Let me introduce myself. I'm a senior applied data scientist at Dhanambi, and today we'll present you our work done in building a chatbot, which converts user queries into SQL. So let's start. I guess all of you here at some point have used ChatGPT to generate insights, to ask questions, and just to casually talk to it. How many of you have tried to upload some data with data analysis and try to do some EDA or get some insights and charts? I guess many of you, yeah. Our business problem is something similar, and we try to build something that is open source on our side. Let's take an example. At Dhanambi, we have several business users who want to leverage the vast amounts of campaign transaction and product transaction data that we have and use this to create some insights quickly and showcase this to the clients. In order to do this, we had some existing tools which are like drag and drop query builders, rule-based chatbots. The issue with these types of solutions is that drag and drop query builders can be quite cumbersome. It will be limited in options, and you may not be able to generate complex insights through it. So the data science team at Dhanambi, we came together and we brainstormed on how to solve this. We decided to leverage the latest technologies, and we built a chatbot which uses an open source large language model that converts natural language to SQL queries. Using these SQL queries, the user can then convert that to text, to data frames, and then get the output insights. These insights can then be shown by the business user to the clients to drive more revenue. In short, this is exactly the business problem we are trying to solve, and we are doing this using open source large language models. So let's look at this in detail, let's explore some of the existing technologies that we have, some of the traditional ways we solve this. First, we have email conversations. So the business user asks us, the data scientist, that this is the data that we want. We want to find out the sales during this period, how these products performed, how these campaigns performed during this period. Problem with this is it is quite time consuming. There is back and forth emails, and there's also time lag due to geography. We are in India, the business users may be in Europe, they may be in US, so this is not feasible. Next, we have drag and drop query builders, which I already discussed. It cannot handle complex queries and it's limited. We have some closed source solutions like Gemini and others. Problem with these solutions is that we will risk exposing our data outside the organization, which we cannot afford to do. And last but not the least, we have rule-based chatbots. Rule-based chatbots are only restricted to the intents, entities, and contexts they're defined by, and they will not be able to understand all types of user queries. So what is the advantage of LLMs over this? Open source large language models, which are trained on vast amounts of data, they can understand almost all types of user queries, and specific large language models, which are instruction fine-tuned to generate SQL queries, can use these queries to get these insights. And we can always improve the accuracy with prompt engineering and fine-tuning that we'll look forward in the following slides. So let's understand this process in detail. How did we proceed with this chatbot and how we build this? In order to build this chatbot, which is powered by open source large language models, our first step was to select an open source model which is feasible for this solution. Next, we performed the usual steps of data preprocessing. We went for prompt engineering, then fine-tuning, and then did some final validations to ensure that our model was robust and accurate. So in short, these are the steps that we followed. Let's look at each of these steps one by one. So first, we have the model selection. In brief, we'll discuss some of the models, some of the specific models that we experimented on. All of these models are free, open source, and commercially usable, and they're available on Hugging Face. So here along the x-axis, you will be seeing the model that we experimented on. You have the accuracies along y-axis, and the bubble size is proportional to the number of parameters. Let's discuss some of the relatively larger models. First, we have NSQL. The 6 billion, it is a 6 billion parameter model, which, as you can see, is around 60% accurate. We have SQL Coder, which is slightly larger, 34 billions. It's around 70% accurate. And finally, we have text to SQL, which is fine-tuned on Code Llama. This is a 13 million parameter, which is around 55% accurate. So with these larger versions of models, even if we quantize these models, we will still need GPUs in most cases. So we decided to look at some smaller models because our use case is very specific, generating SQL queries. So some of the smaller models that we tested, we have VQSQL, which is fine-tuned on T5 base. This is a 220 million parameter model, which is around 35% accurate. And finally, we have the 350 million parameter version of NSQL, same as this one, which is around 55% accurate. The good thing about this final model is that, as you can see, it is quite small. And because of its size, it is much faster than all of these larger models. And we can just even get the inference on a CPU. Even without quantization, the inference time is just 5 to 10 seconds. So we can generate SQL queries based on these inputs in just 5 to 10 seconds. With quantization, that improves even better further. And we will look at how we improve the accuracy further with fine-tuning. So in short, these are the models that we experimented on, and we finalized on the 350 million parameter version of NSQL. We'll look at how we performed each of the steps and proceeded with the chatbot. First, we have the usual data preprocessing. As you all know, every organization will have challenges with the available data, like having a lot of null values, a lot of outliers, inconsistencies in the numeric and text data. So we fixed all of these issues, and we created a cleaned and transformed data frame to feed into the model. After doing this, we proceeded to the next step, which is prompt engineering. So why do we need prompt engineering? Why can we just directly type in that this is what I want and pass it to the LLM? Because after all, it will generate the next token and give me the SQL query. The reason we need prompt engineering is because NSQL was originally fine-tuned on Salesforce's code gen, which was specifically for generating code. And it was fine-tuned using a specific prompt structure to generate SQL queries. So when I want to use this model, I need my prompt to be in exactly the same format. What is this? And that is where the magic of prompt engineering comes into. What was the structure of this prompt? First, we have the column names. Then we have some set of instructions, the schema, and then we have the user query. At this step, we have the basic structure of the prompt. We can pass this prompt to NSQL and get the SQL query. But will it be accurate? It will be in some cases, but there is some further improvements needed. The first step that we need to check is, as with any large language model, it tends to hallucinate. We will type in that, okay, I need the sales data during this period for these particular brands. It will generate the SQL query, but let's say instead of brands, it will select some other column, or it will have some specific column generated which does not even exist in the data frame. This can happen sometimes. In order to prevent this, we need to give some specific instructions in that prompt to ensure that it does not hallucinate. The next step that we focused on is in the user query. So when the user types in that this is what I want, there'll be spelling errors. There'll be like synonyms, like let's say instead of campaigns, or instead of, let's say, the ID of a campaign, I use like a different word like Intel or some other word. In such cases, when the large language model generates the SQL query is also likely to contain that word, as long as it is a technical word. So for normal words like sales, it will be able to recognize synonyms, but for technical words, it will not be able to do that. So instead of looking at this problem in a much difficult manner, we thought of simply fixing this in the user query. We maintained a synonym dictionary, which contains some of the popular words that are used by business users, some of the popular synonyms that are used by business users, and using fuzzy matching, we matched the user query, the keywords in the user query, with the actual column names and some set of data that is present in the values, and then replace that in the user query. After all of these 4 processes, we have the final prompt. We have the basic prompt structure. We have the instructions to prevent hallucination, and we have fixed the spelling errors and the synonym issue. When we pass this prompt to the model, it is now able to recognize, understand, and generate the SQL query accurately. When I discuss about the models that we tested, NSQL 350 million parameters was around 55% accurate. After this step, it improved by around 10%. So is that enough? Can we just stop at this stage? Like we have a foundational model and it is working fine in most cases. So can we use this? We can, but there's one more step which can improve this. Since we are using a general purpose foundational model, in order to ensure that it is accurate on our business data, that is campaign sales data, we have to fine tune it on that specific data so that it is far more accurate. And that is where fine tuning comes into the picture. So let's look at the process in detail. Based on a campaign data, we created a set of instruction and SQL query pairs. What are these instructions? These instructions are basically the same prompt structure that we discussed in prompt engineering. It has to be in the same structure. And we have the SQL query pairs corresponding to these instructions, which, and these queries are what we expect from the model as output when we pass these instructions. So we have these instructions and SQL query pairs created, and using this, we perform parameter efficient fine tuning, which is the norm nowadays on NSQL, and we were able to obtain accuracies of up to 80%. We at the point of publishing this research paper a few months ago, we had tested it on 450 queries, and of late we tested it on more queries, of which 45% were unseen data, and we maintained accuracies of up to 80%. So and this is the process of fine-tuning that we followed, and as a final step, we did some output sanity check. So it can happen that sometimes the SQL query is being generated. When we run this SQL query on the data frame, the data being generated comes out as we expected, but the SQL query is not fully accurate. This can happen sometimes. So we ran some automated sanity checks to ensure this was accurate, and that concludes the technical details of our chatbot. So this is the full details of the chatbot that we have worked on for this research paper, and we created a user interface with Streamlit where the media planners, where the business users can easily type in what they want, and they can generate these SQL queries, and insights based on it. So let's have a recap what we discussed. So large language models have a specific advantage over these traditional methods because they are not restricted by rules, and they do not have the complexities as well as difficulties that we have with some drag and drop query builders where it cannot generate specific insights. And specific large language models like NSQL 350 million, which we chose, can convert this into SQL queries because that's how they have been instruction fine-tuned. We decided for this specific model because this has a good balance between speed, accuracy, and size. It can run on a CPU. And we talked about in detail about how prompt engineering and fine-tuning improve the accuracy of the large language model. So all in all, the main purpose of this was to shorten the duration and make it very easy for business users to simply type in the query that they want and generate the insights, instead of involving us data scientists through email conversations or using cumbersome drag and drop query builders. So we no longer have to write several PySpark SQL queries, sit and then provide these insights. That's all about our chatbot. Let's look at some of the things that we are working on currently. We are looking at continuously improving this model even further. We are taking feedback from business users and as well as how the business is evolving with time, what are the new requirements that are coming in, and continuously improving it. One of these is increasing the capabilities of the chatbot to not only get these insights and data frames, but also generate charts, plots, summaries, and some extra insights which we do not get from NSQL. If I briefly mention, we are basically chaining more large language models together to get this output. We are also testing the SQL Query 34 billion model, which I initially mentioned, on a GPU instead of a CPU. And we are benchmarking it against closed source solutions like Gemini to see how it performs. And lastly, we're also looking at human feedback in the chatbot to perform reinforcement learning. And we are also looking at direct policy optimization because our business users, when they look at these insights, they might think, okay, this is correct. But they might give a like feedback and they might say that it's correct, but it may not always be accurate. So we are also looking at direct policy optimization to further tune the model. So that's all about us. This is the team. This is the team at Danambi, and you can reach out to us at LinkedIn. Thank you.